Welcome to the Panorama Room. So up next we have William Brown, who is a senior software engineer at SUSE Labs, and he'll be giving a big live demo of Kanidm. Please make him feel welcome.
Thanks, everyone. As Sherelle just so kindly introduced me, yes, my name is William Brown. I'm a senior software engineer at SUSE Labs. In my day job, I specialize in identity management and authentication. So I work on Kanidm 389 directory server, which is one of the major LDAP servers commonly used in FreeRPA. I also am the developer of WebAuthn in Rust. For people who are watching the recording later, because I'm based in Queensland, Australia, if you have any questions, my email is the best way to get in contact me, and that is wbrown@suse.de. And of course, today's talk, like most of my, well, actually not most of my talks, but we're going to be talking about authentication. And people often think of very different adjectives about authentication than someone like myself might. And so I did a very unscientific survey the other day online and asked some people for words that they associated with authentication. People described it as unfriendly. It was difficult to engage with. It was hard to actually approach. It's complicated. It's difficult to understand. The moment someone says Kerberos or LDAP, people go running for the hills. It's fragile. When it falls over, it commonly falls over, breaks, and then it becomes difficult to debug and understand why it broke, let alone fix it and repair it. But more than any other word, by probably an order of magnitude in the survey, the word painful was used to describe authentication. And given all the nods I'm seeing in this room, I think this is the majority experience that people have. And you know what? This is the experience that I had as well for a long time. And I think this has led a lot of people to really shy away from authentication and not want to touch it or run it in any kind of environment. But it's so important. Every day we have to authenticate to our laptops, businesses, schools, systems. So because of this experience that I had with unfriendly, painful authentication, I decided to put on my developer hat and, as an underachieving white man, decided that I could tackle this problem once and for all. So I have started developing Kanidm. Now this project was started, I think, in 2018, and I've been working on it since then, and we've had a lot of community growth since then. And it's an identity management service. Who would have thought? And the goals was to really be simple to deploy, extremely reliable, and correct and secure by default. So the project is hosted on GitHub at the moment. You can follow the link there. But rather than listen to me give a whole bunch of slides about what Kanidm can do, I have made the extremely daring decision to just demonstrate for the next half hour what it can do. Now, everything I'm about to demonstrate is documented publicly online. We have an extensive book and documentation. It has commented server configurations that you can copy paste in. We have guides on hardening, how to install things, and go from there. So let's install Kanidm. That's where we're going to start. Now, my little laptop here is running some VMs, and we tend to deploy Kanidm in containers. So the first thing we're going to need is we need a Docker volume. And like a good TV chef, I've prepared commands earlier, which I'm copy pasting in. And so we need a volume to store our data. Unlike a lot of other auth services, we are the database. You cannot back Kani onto some other SQL service. This is the database. You have to have state. And there's a lot of design decisions for that. So now that we have our Docker volume where we can store Kanidm's data, we're going to create our container. Now, not a very scary Docker create line. We need to expose port 443 for HTTPS, 636 for LDAP-S. And the reason for this is that TLS is a requirement for secure communication to any service. And this includes LDAP. People say use start TLS. Do not. It is insecure. There are actual exploits against it. Don't use start TLS. You need to use LDAP-S. This line here, the OpenSSL legacy config, this is not actually normally needed. This is needed for something in the demonstration that I'm going to show later. No questions, hand down.
I need a larger font.
Okay, I can do larger font.
Sorry.
Yeah, thanks. I'm getting 5 minutes extra at the end because of this, thanks. All right, where's font? How's that? All right, there you go. So the legacy OpenSSL-conf is for something later, and I will call that out when that comes up. Unlike most people who say, I'll talk about this later, I'm actually going to talk about it later. This will not be forgotten. And obviously, we mount in our Kanidm volume, and we pull our server image and go from there. I am cheating. I'm using a development image just because of some stuff I want to show, but there are stable images, of course. So we're going to start that up. So we're going to create that. Now, you'll notice we haven't started it. We still need to configure our instance. Kani tries to make this really easy to actually get started with. We only need to actually configure one file. So we have a single config file, which is our server.toml, and it is heavily commented about how it works, what it does, and what you need to do. So we have our standard things, bind addresses, database paths, optimizations for file systems, things like that. Where our TLS chains and keys are, which of course are required. But the important values are down here at the bottom. The domain name, which defines where cookies will be shared, so that needs to match with DNS names, and the origin here, which is the URL that you're going to access this instance at. You'll also notice at the bottom we have online backups. So during this demonstration, my instance is set to back up every 5 minutes. And at the end of this presentation, I will show you all of those backups. So you don't have to think about running backups. It's done, they're written out stable to disk, and it makes it so easy to actually then use other pieces of backup software to deploy those and get those backups elsewhere. So with that one server config and our TLS chain and key file, which I have helpfully prepared earlier, we've now copied those into our Docker instance, and we can start Kanidm up. So let's start that up. And if we look at our logs, we can see here at the bottom, our server is ready to rock. Let's go. That's it. We've set up an instance. And if we, thanks, because I adjusted the fonts, it's mucked up my windows. Thank you very much. I did so much preparation for this. I even checked all the screen sizes, and of course, something immediately happens. Anyway, so we are going to go to our demonstration page, and there it is, already working. Now, all done. That's it. Demo's over. No, I'm joking. So with that, there we go, that's the problem. So the problem with that you might be thinking is, okay, great, you've set that up, but I haven't seen you set a password for a default admin. Are you doing that naughty thing and having a default password? Absolutely not. None of that here. We don't ask you to set that password in a config file because we don't want you to write it down. And we don't set a default password because we don't want there to be a default password, because that's how people get exploited. So instead, the process that we use is, because someone being root on the instance is obviously going to take over everything you know and love, whoever is root on that machine can do an initial account recovery. And that will generate a new password for our admin user. So right now, I'm going to run that command here. So I execute in the running container the account recovery process. And there we go. I now have recovered that default password. So you'll see that this is a very nice password. Very, very good. Great. We've got an admin account. We have a password. But how do we actually log in? Now, this admin account, to prevent people using it day to day, cannot log in the web UI. We keep that all away. We don't want you to use this day to day. This is just a break glass account to get stuff started. So we need a command line tool that is going to then bootstrap the initial setup. So to configure the Kanidm client, we just have our config file here. It's very easy. It's just the URL and the path to the CA that we're using. No complicated config, just where to go, who to trust, that's it. So we can now log in as our admin account. Sorry, I need to actually make sure I copy paste things properly. It's very weird to type on a desk that's at the wrong level. Anyway, that's it. We've now logged in as our admin. We're basically good to go to start configuring our instance. So one of the first things you would have noticed here is that this is a little bit bland. We need to, zhuzh this up a bit. That's what my friend says. We need to make it look a little bit nicer. So let's get something a little bit more on brand here for our conference. So what we're going to do is we're going to use our newfound administrative powers to have a look at the options for our domain. And we have this really extensive administration command line tool, tons of help options, try to be very self-descriptive with commands. We make a very big point that the CLI is not an API, so we will change these as much as needed. So they can't be, you don't use these in a script because we will change these for human interaction if that ever happens, because we want the commands to be friendly to people. So we can already see here some things that might help us, like setting a display name or setting a new image that we can use on our instance. So we're going to, again, good chef, I've prepared some commands earlier because we are here at everythingOpen 2025 Adelaide, and the event organizers very helpfully sent me through the logo so that I can set that on the instance. And I will now refresh the page and it's already taken effect. So Kanidm has, most of its configuration is actually in its database, and that is because with replication, it will configure every replica all simultaneously, and all of those changes take effect as soon as you actually commit. There's a whole bunch of stuff in there, so again, talk to me after this about how that works. But yes, we've done a lot of stuff to make sure the online configuration works and is very, very polished. So we now have our really shiny looking identity management platform for everythingOpen 2025, but there's no people in it. Let's start making some people. So we believe in privilege separation. So we have an admin account which administers the instance as it exists, and we have an IDM admin which administers people. The two cannot recover each other's passwords. They are separate things. They are designed with privilege separation in mind. So say the system admins can't read private data. The people who read private data can't go and administer the system and try to like add extra data sources and accidentally leak it somewhere. So we really try to separate privileges, and each of the admin and IDM admin is actually built up of a bunch of smaller privileges which you can hand out in small, fine-grained ways. So what I'm going to do is, same as before, recover my IDM admin, log in as the IDM admin here. Oh, good one. Sorry, did you see my password? Anyway, so we've now logged in, and now we can go ahead and start creating a user. So I'm going to create a person, and again, oh, sorry. There you go, there's your demo mistake that I made. We can create a person, again, got all the nice help options. So we need to give them an account ID and a display name. Now, the problem that we have is unfortunately Linux exists, and Linux limits usernames to ASCII only. So when you create a person, unfortunately, their username does have to be ASCII only, and we do have some strict rules on that. But your display name, now that can be whatever you want. You can have emoji in your display name. So I'm going to do that. So of course, this also works in terms of like helping people with other languages and you know what they want to be displayed as, but we support full UTF-8 and display names. So we've created our user now, but we need them to be able to log in. And I don't want to know their password because that's silly. I'm going to make sure that I can send them something so they can administer their own credentials. So I'm going to create them a reset token for the test user account. And you'll notice here, by the way, because I've got two logged in session, I'm given this nice little interactive dialogue to choose which one I want to use for that command. So that way it makes it really easy. If you've got a couple of accounts, you can actually choose which one you're using, and there's some more information there later. Not authorized. There you go. This one is authorized. And as you'll see, you get a QR code. And if you follow that with your phone, you can give that to the person, they can scan it with their phone, they can enroll that. There's a link they can follow, or you can update the credentials on the command line. So in this case, we are going to follow this link here. And the token code at the end of this URL, you can also just send them in a letter. There's a form they can enter and go to that page. So we're going to update our credentials for test user popcorn here, which is displayed properly, of course. And we have the option to set up passkeys and alternative authentication methods which we deprioritize, such as passwords. So in this case, I'm going to set up a passkey. Now, you can't see it because Lectern Chun here with her cute little googly eyes is in the way. I have a YubiKey in my laptop. So I'm going to add my passkey. Now, Apple really likes to guide you to use Touch ID, and you have to do a little bit of menu diving to get around that, unfortunately. And I'm now going to touch my key. Did you get my PIN? Anyway, I've now added my passkey, and I'm going to add that to my account and save that. So we've now set up our user. We have a passkey, no password, no whatever. Passkey is self-contained multi-factor cryptographic authentication, which is awesome. I'm going to log in as our user here, touch my key, and that's it. We've now logged in. We've got a user, hooray. But we have a few other cool little details here to really help people out when they're coming on board. So a lot of passkeys don't work between multiple platforms. So for example, you might have an Android and a Windows device or a Mac, and you can't synchronize. So we actually have a way that a user can self-enroll other devices. So I'm going to select enroll device here, and you'll see I'm asked to re-authenticate. This is because every session in Kani is by default read-only, and it might last for a day or a week or whatever, but you need to use a sudo mode, which gives you very limited privileges for a short period of time to prevent use and damage of that token if something happens over a longer period. So I'm going to use my passkey now and log in once again so that I can now access my own account, and I can now give myself that QR code. So any user can just get their own QR code out and sign in another device and make it really easy to enroll disparate devices with cryptographic authenticators without having to shuffle around a password or TOTP between their other devices. We really try to make this as accessible as possible for people to access those cryptographic authentication methods. So you may have noticed on the front page though, that we have this thing called an applications list, and it's looking a little bit bare. So there's no real point to having something like an identity management system if you can't use it to identify yourself to other systems. So unlike a lot of other systems, we don't require external providers for things like OAuth or OIDC. We are the provider, and so we can now actually add in an OIDC provider here. Here's Nextcloud I prepared earlier. So I've already configured the Kanidm client because obviously the point of this is not to show you how I configure Nextcloud. This is all documented. Again, we have all of this documented in our book. But part of the way that OAuth 2 works is that both sides of the equation need to actually know about each other. So Nextcloud needs to know about Kani, and Kani needs to know about Nextcloud. There's a mutual authentication going on here as Nextcloud has to trust what Kani is saying, and Kani doesn't want to be giving out tokens to just anybody. So we're going to come back over to our command line here, and we are now going to set up Nextcloud. So what I'm going to do is I'm going to tell Kani that I'm creating a new application, which is Nextcloud here, and its URL. So when a user wants to log in, they will be taken to that URL. So great, we now have a Nextcloud instance. But we need to control who is allowed to log into Nextcloud. We have groups for this, and we want to make sure that only members of a certain group can log into Nextcloud. So we are going to create our Nextcloud access group, and of course, Mr. User Popcornington is the person that we are going to be logging in with. So we've now created our Nextcloud access group, and our test user is now a member. So that's Kani's side done. Kani now knows about Nextcloud. It knows who should be allowed to log in, and our test user is allowed to log in. But from the Nextcloud side, it doesn't have a concept of groups. openid-connect and OAuth 2 only knows about scopes, and it requests from Kani, hey, I will let someone log in, but they have to have these scopes. So we have to have a way of mapping these to each other. So the way that we do this is we have what's called a scope map. And we can do like mandatory scope maps and supplemental ones so that when someone logs in, they can be granted extra scopes on top that aren't just there for the authorization process. That might give them like an admin console or something like that. So what we're going to do here is we are going to set up our scope map. So for the OAuth 2 scope map for Nextcloud, for the Nextcloud access group, so each scope map is unique to each OAuth 2 provider as well. There's no like link. Each OAuth 2 provider is separated as well, cryptographically too, so that there's actually blast radius and like isolation. And we're going to, in the future, we might allow like combinations of them to be put together. But what we need here is we need to know what scopes Nextcloud is going to request. So here, it might be a little bit small, but it's OpenID, email, and groups. And if people know about OpenID, you're going to know that email means it's going to send us email addresses. So that's personally identifiable information. So we're going to do that. And we now need to let Nextcloud authenticate. So we're just going to grab the basic secret. Again, you'll notice I don't let the user put the secret in. We have to generate it because I want you to be using good secrets. Anyway, so that's Nextcloud done, and we're set up. So I'm going to log out of the admin. And as you can see, I can now log in with Kanidm. Gotcha. This one was intentional. You all thought it was a demo and there was an error. You're all wrong. I set this one up. So, what have I done wrong? Well, the error doesn't really tell us anything here, but we have got this operation ID. So what does that mean? So I'm going to grab this UUID here. I'm going to come back over to my Kani server. I'm going to show the logs for Kanidm. And I'm going to grab that UUID. It doesn't render very nicely here, but you'll see that UUID associates to these log lines. Every operation on the server has a unique operation ID, regardless of which server it's on. It is always sent back to the client, and we have this tracing tree that we have. It formats a little bit better on a larger screen, and it shows us exactly the context and sequence of events that occurred to cause that error to happen. So we have this really nice way of you finding when something went wrong and what went wrong and why it went wrong. So we can see that here there was a request. It has timing information about the request, so if you have a performance problem, we can show you that. And it also shows you like subsections of that. So you've got like the inner performance too. So we break down that, hey, half the performance occurred in this section of the function call and the other part occurred here. But of course, this is the bit we care about. Invalid OAuth to redirection URL. It must be an exact match to the redirect URL. I was sent Nextcloud EO demo apps user OIDC code. Great. That's because what's happening is in OAuth, Nextcloud tells Kani, hey, redirect me back over here with the user's token. Kani doesn't know that that's a valid redirection URL. It could be to somewhere in Russia. I don't want to send your token to Russia. I need to know exactly where I'm going to be sent so I can validate that and strictly attest that this is the right place to go. So what we're going to do is we're going to fix that up, and we're going to clear that. And you can just, of course, copy that URL from the error message, but I'm going to come back here, reload the page, log in. There we go. So we've made progress. Now, you might be wondering what this consent to proceed is. So because OpenID asked for the email claim, email is personally identifiable information. So we ask the user, hey, do you consent to this? Do you want your email shared with this provider? And so we ask the user to consent to proceed, and anytime those scope relationships change, whether it's added or removed, we always re-prompt for this consent. We really want the user to know where and how their data is being used with other providers. And this is really important, not just in a workplace, but also like personally, because if that changes, it could indicate something fishy is going on. So right now we're going to proceed, and it's going to take a second. Now, Kani's actually already done. It's Nextcloud that's taking the time here, not Kani. And there we are. Straight into Nextcloud, and you can see even our emojis come through properly in the display name. So that one's a really fun one. All right, so great. We can log into websites. We've got an identity management portal. Actually, I forgot to show you. Here we go. So we come back here to our application list, and there's Nextcloud. You can only see applications in this list that you have access to log into as well, by the way. So this only shows test user that application because it has the necessary and requisite scopes to log into it. So this is a really nice way of just having like an auth portal to people can log in and then single sign on and go to other applications, and it just makes it really nice. I use this all the time at home. I use this to like get into my Nagios and LifeX control and all that. It just makes it so nice as like a home page. And of course, if you click that link, you will be immediately taken to Nextcloud. And if you weren't already logged in, it'll trigger the single sign-on process and the whole works. So, great. We've got our IDM set up. We've got a user. We can log into Nextcloud. We've got an application portal. I can enroll my other devices. But I also have Linux machines that I like to administer because I run a home lab, and I'm a bit of a nerd like that. Who would have thought? So what I'm going to do is I'm now going to set up my test user here to be able to log into Linux machines. So I'm going to do POSIX set on test user. So what this is going to do is this is going to set up POSIX attributes on the test user. Now you might notice, actually if I do --help, I have to set the account ID that I'm doing it on, but you might notice that there's only GID number and shell. There's no UID number. That's because in Linux, the user's primary group is functionally security equivalent to the user's UID number. So it doesn't matter what we set. We only, don't shake your head, it's correct. I'm the one giving the talk, not you. So the GID number implies the user's UID number. So we only set that value. And of course, we can automatically generate that when we actually set this. So we're going to set that up on our user. So now they've got POSIX attributes. And we're going to set up our user to give them an SSH key. So I've now moved back onto my laptop here. And I'm going to log in on the command line as the test user. Now you might recall, I didn't set up a password for my test user, did I? But I can use my YubiKey and my passkey from the command line. Oops, there we go. So I've now logged in with my YubiKey on the command line, the same YubiKey I enrolled in a browser, and it works here as well. So we really put a lot of attention into making sure that that'll work. We actually had to write a CTAP library to do this, so if that tells you anything. So now that I've logged in as my test user, I can self-administer aspects of my account. So, for example, I can now do a person POSIX set password here. Oops, sorry, I need to target myself. Now, you'll see, again, remember in the web UI, you had that thing where it had to ask you for your passkey again to write to your own account? Same thing on the command line. This is asking me that and saying, hey, you don't have a read-write on your command line session, re-authenticate and prove that. So this is so that if a stale session is ever left on your laptop gets stolen, it can't write to your account, it doesn't do anything. This privileges only last for a very short window of time. So I'm going to re-authenticate. And I can now set, and you see it's very clear, a new POSIX password. Now this password will never be allowed to actually log into my Kani account. This is just used for sudo and logging into Unix machines. We separate those two so that in the event that one is compromised, it does not compromise the other. We really want separated credentials with limited blast radiuses and usages. We really want to encourage people to be using password managers and things like that too. So I've set my sudo password. I'm now going to set up an SSH key. Now you'll notice again, this is an ECDSA SK type. Again, I'm big on the security key train. Some providers still to this day do not support uploading YubiKeys with ECDSA SK types. We do. So I'm going to generate that. My PIN, by the way, is 1234. So I've got an SSH key now, and I can add this to my own account. So I can add public key for myself, and I'm just going to add that public key here. Awesome. So my account is now set up. It's got POSIX attributes, an SSH key, and a sudo password. Now I need a machine. Here's one I prepared earlier. So this machine has already been slightly pre-configured because that is the reality of Linux is that setting up PAM and NS switch sucks. I've already done that for this demonstration. So I will show you that NS switch is set for the Kanidm modules. We have written our own PAM and NSS resolvers. And they've already gone through security auditing by the SUSE security team, and they were very impressed by what they saw. So if you want to talk to me about that, please do. And we also wrote our own PAM. So this is the PAM side. Now, those of you who are very familiar with Linux auth will notice something is missing in this file, and that is the distinct lack of PAM Unix. That is because PAM Kani can actually replace PAM Unix, so that we can, in the future, do a whole bunch of other really interesting things to try and improve security of users on a server and a Linux system. So this replaces like Etsy password and stuff like that. So we have already configured PAM and NS switch, and we have a resolver that runs on the machine. That's a separate process which is hardened and has a bunch of security hardening on it so that people cannot exploit it. It can do things like caching credentials and caching SSH keys. To configure that, again, like our client before, same config file, but we also have an extra one here. Sorry, I should use Vim. And this config defines how we configure the Unix resolver. Keen-eyed who are looking will see this first configuration section. We are the only PAM module that supports a TPM. We can actually bind your credentials to the TPM of this machine so that when they're cached, if they ever get stolen, they cannot be used. They are bound with that, and they actually require you to be on that machine. So this is another layer of protection, and we go a long way to make sure that we're always using like the best current standards for cryptography and protection of your credentials. At the bottom, I'm just flicking down. Again, like our other configs, very highly commented. You'll see that we have this PAM allowed login groups, which is the group that is allowed to log into this system. So our system is set up, our user is set up, but we need to give them authorization to log into this machine. So I'm once again going to create a group, which is the Unix allowed login group. And as before, we need to give this group POSIX attributes, else it will not be able to resolve on that machine. So we're going to do that now. And we can do add members. You can see I'm getting a little bit overconfident because I'm actually typing. So you can see we've now added our test user to our machine. And I'm not even going to check on the machine if that's working. I'm just going to SSH in. So I'm now going to SSH with the correct public key. Oh, I know what I did wrong. I forgot to start the resolver that I was just talking about. See, I told you I was getting overconfident. So I'm going to start the Kanidm Unix resolver. Now, you'll see that it's taking a second to start. This is because at startup, what we're actually doing is we are benchmarking your CPU to determine how many rounds of Argon2 ID we can apply to hashing your password. The reason is that we want to do as much as possible that doesn't expend a certain time limit. So rather than just using the minimum that's recommended, we're going to try and go above that amount to a time window, which also means as CPUs get faster, we automatically do more, which is great. Improve security just by waiting. We're going to start the task statement, which is our equivalent for oddjobd, which does home directory setup and creation. Again, separate process for security reasons. Now to work. There you go. So now I touch my SSH key, and that's it. I'm in. So I've now logged into my machine, and you can see that I'm here on my as a test user, and I've got my Unix allowed login group. I've had a home directory created for me by that UnixD tasks, and we're all good to go. So what I'm going to do now is I'm just going to touch a file just to prove that it works. Hello, everyone. Hi. OK. Now, something that generally freaks people out is people changing their name, especially identity people. Who's had problems with changing their name on an identity service? Yep, there we go. So what I'm going to do is I'm going to show you something that will scare a lot of people right now. So remember, on this machine, I'm currently logged in as the test user. So what I'm going to do is I'm going to do Kanidm. Oh, sorry, I'm just actually going to copy this one. By default, we let people change their own username. So I'm going to update my username to be the word meow. And I'm going to immediately log back into this system. Who thinks this is going to break my home drive? I can hear a giggle in the audience. I'm going to touch my key, and I'm now meow on my demo machine with a new home directory path, and all my files still exist and still belong to me. Yeah. So that was the big magic trick. We put in so much work to make that happen. Now, we do have an access control which can remove that, because we do know there are some environments where people may not wish to let people change their names. I think schools might be an example here, because kids are little chaos goblins. So yeah, so I can imagine that you're all, quite a few of you are sitting here going, man, that looks so cool.
Man, that looks so cool.
Thank you. I appreciate your enthusiasm, Matt. And you might be thinking, yeah, I really want to migrate, but I'm already running something at home. And I can see that glint in your eye, Fraser, that you really want to give this a go. Here's my free IPA instance that I prepared earlier. And I have given Fraser his own account. And of course, you might notice here in the bottom, it's a bit small, but I've added 10,000 users to this instance and 5,000 groups. And I'm going to migrate them all to Kanidm right now. And some of you might be thinking, you are a mad lad. You are unhinged. So that is actually true. Can confirm, am a mad lad. So I am going to create an IPA synchronization. Now, the way that we do synchronization, it's not all big bang. We actually have a synchronization tool that runs over time and can run in parallel for an extended period and treats IPA as superior auth source, keeps pulling things across. You can move applications across one at a time, and then when you're ready, you can finalize that and move authority of the data over to Kani. So we really thought a lot about how to do this migration. Sorry, actually, I've got to log out of this here. And actually, just to prove something here, so I'm going to log in as Fraser. I've set up Fraser with TOTP here. Hang on. I've got to copy-paste the code. Yeah, I already have that on my Mac, and it will cause too many problems. So anyway, so I've got to copy-paste the OTP in here. So just to prove this, Fraser does exist. He has an SSH key and requires TOTP to log into his account. These are important details I want you to remember, okay? Because Fraser believes in security, SSH keys, MFA, good stuff. So I've created my synchronization agreement. And what I'm going to do is, since users of FreeIPA will still need to update their credentials in FreeIPA, I'm going to tell Kanidm, hey, if a user with FreeIPA logs in, tell them to go over here to update their credentials. So I'm going to direct those users from, sorry, I did that with the wrong account. And I'm going to direct them over there. I'm going to then generate a synchronization token, which is how the synchronization tool will authenticate to Kani itself. Sorry, please don't copy that down. And I'm going to set that here. Now, again, we have a cron-like scheduler, and I've already pre-configured this with the URL and the needed credentials. You can do it without Directory Manager. There is a way. I was just lazy. There's a little bit of pre-configuration on FreeIPA you have to do, but that is, again, all documented in our book, and it's really easy to actually set up, and it doesn't break anything on the IPA side. So what I'm going to do now is I've set up my IPA sync, and I'm going to run that tool. Now, this mounts in a whole bunch of stuff. We have to mount in our config-defined Kani, the CA certs, the IPA certs, where that synchronization config is. And I'm going to run that tool, and I'm just going to do a dry run here first with -n. So this is just going to check all the data in FreeIPA and what's in Kani and make sure that we can proceed. So that is now succeeded. And I'm now going to migrate those 15,000 entries here. And I think a lot of people, if I was to tell them about this, they would say, wow, that's going to take so long. I think the last person I asked how long it would take, they responded with something like half an hour. But it's actually a really fast process, and it's already completed. So that completed in 12 seconds. Now, I also hamstrung myself. I actually only gave the Kani VM that is running this 1 gig of RAM and 1 CPU. So this is running on as minimal hardware as I could possibly get away with. That is actually like the boot minimum limits for opensource. So I have really made this hard mode for myself. So now what I can do is, now that that synchronization has succeeded, I can now show that Fraser has been migrated in. We have Fraser's SSH public key here and everything else. I can go over to our web UI, and I'm going to refresh that, and I'm going to sign out. With my password manager here, I'm going to use Fraser, and it automatically completes his TOTP and password properly because I've already set that up in my password manager, and that's it. We've logged in as Fraser already, and if I go to update his credentials, you'll see that it says here, hey, this account is externally managed. Some features are not available. Go visit the external account portal. This will take you to FreeIPA. So if Fraser wanted to update his account, he has to go back over to FreeIPA here. But we have another trick. We have the concept of you can yield an attribute, which says, hey, actually FreeIPA can't set this attribute. We give it control to Kani, because Kani by default respects that FreeIPA has control over all that data, and we don't. So what we're going to do is we're going to tell Kani, hey, actually, you're the one in control of passkeys. And we're going to now set that. We're going to come back here, and we're going to refresh our page. And we can now add passkeys to Fraser's account, and they are stored in Kani and can be used on that command line as showed before. These aren't related to the FreeIPA's instance of anything, but Fraser can still log in with his password and TOTP and now have passkeys on his account going through our single sign-on portal as well. So you can run this in parallel. Fraser can keep logging in, use it as an identity portal or an OAuth bridge while running FreeIPA in the background and doing that migration over time. And of course, just one last thing. Actually, there's a couple of last things. We're going to add Fraser to be able to log into our Unix allowed login group. We're going to log out of Meow. And here is an SSH key I prepared earlier. Fraser was very kind enough to give me his SSH private keys for this demonstration. I really appreciate that. Very trusting of him. And I'm going to log in as Fraser to our machine, and there we go. He's straight in, and he even has the same GID and UID numbers as he had in FreeIPA to aid with that migration. We've even carried over his shell preferences and home directories. So that's that. And so the reason why we actually needed that SSL legacy config, by the way, is for this migration. It's to import the password hashes from FreeIPA. So we needed that config to enable some cryptography that we don't normally have. And the last thing that I said I was going to show you was, do you remember how I said there were backups happening in the background? Oops, sorry. Am I on the wrong machine? Yes. Yep, cool. No, I've typed it wrong, is actually what's going on. That's awkward. No, this is not, something's wrong here. There we go. There's the actual error in the demo. Well done. Yeah, I don't know where the backups are. They are running, so I'm sorry that one was a Docker volume ls. Let's do some debugging. Surely that's there. Anyway, I'm going to give up on that one. Sorry, the backups were there. I've done this demo about 10 times in the last week, and every single time it's there. Like, I have a script on my iPad to the left following this, and it's always worked. So there you go. There's your demonstration fail. I did tempt fate, and fate got me. No, they run every 5 minutes for the demo. So that's so that was that. Anyway, so thank you. There we go. We had one failure. So I've just shown a bunch of strengths, but I also acknowledge, like any project, we have weaknesses. Our web UI needs a lot of work. That is an area that we've been very late on. We're just adding that in. It's very barren at the moment. We have a couple of people who are really beginning to start adding administration side of that and like some of the more dynamic admin parts. So that's really expanding at the moment. We don't have internationalization yet, but we are starting to lay the groundwork in for that, such as like having different language display names and different language legal names depending on how they are represented, depending on language characters and things like that. We don't have SAML support, and we probably never will, because SAML is a remote exploit that happens to sign you into websites. And of course, like any open source project, we have growing pains. We're starting to like grow as a community and you have to work out like, okay, how do we deal with new maintainers? How do we trust them? What are our review processes? Things like that. But I'd like to think we do have a lot of strengths that I've shown to you today. Like, it's an all-in-one system. It's very easy to trace errors. It's very lightweight. Like I said, that was a typo. Yeah, it's 1 CPU, 1 gig of RAM for this demonstration. Tons of documentation. Everything I just showed you is documented. We are the only PAM module to use TPMs for protection of secrets. We're definitely the leader in WebAuthn. So we were the first open source identity management service to support WebAuthn. We're the first to do passkeys. We're still the only service in the world that does attestation, which is cryptographic proof of where an authenticator comes from. So you can actually control, hey, I only want YubiKeys but not Nitro keys because they're broken. But the best thing is how easy it is to get started. Like, it's git clone, cargo test, and you can run our full test suite. We make this so easy to contribute to, and we just have the nicest community of people. I really adore the Kanidm community. They are just wonderful. And I really hope that with this project, we can change the adjectives that people use when they think about authentication. And I want that to be words like accessible, respectful, secure, and friendly. And that's what I set out to create, and I really want that to continue, and I think that shows in the people in our community, and I really, really appreciate them for their support. So again, more information, our project is on github.com/Kanidm, and we have links to all of our communication services, how to raise issues, the book that I just showed with all of our documentation. Everyone is always willing to help, and if you've got a problem, we're always there, so we really care. Anyway, thank you very much for your time, and I'm sorry, I'm just about out of time, so there's probably like a little bit of time for a question. So, yes.
You've got a quick question?
What happens if you change the username while the user's logged in?
Good question. So if you change username while the user is logged in, the next time that the get ent request comes back, it will update and should show the new username. But the problem is that when your shell starts, it caches that. So you have to log out and in to actually show the new username. So the resolver actually does the right thing and immediately updates and knows that the username has changed, but your shell won't until you log out and in, because the shell caches that information from first run. I think I did test that during my testing. So the other thing we support that's really cool, I didn't have time to show. I did have bonus, but I was like, no, I'm too close to time. We support multi-active node replication, and I was going to show you how easy that is to set up. So you can do like proper HA. We wrote like eventually distributed database replication, and yeah, it works really well. Like, we've had people running this and forgetting about it. We had one person recently who's been running their instance for the last 1.5 years and forgot to upgrade. So now they're having to go, oh no, and they've got to like upgrade through the versions to actually get them to upgrade, because it's been really reliable for a lot of people. So yeah, and there's one member of the community who is just an absolute mad lass, and she just does everything with replication that is wild. So, yep. Anyway, thank you for coming, and if you have any questions, please come see me after this, and I hope you enjoy the rest of your conference.